In this video, we will discuss how to graph higher degree polynomials. First, to discuss what is a polynomial graph and what is not, on the left-hand side, these are both considered polynomial graphs because they are continuous flowing functions. On the right-hand side, in the top, this is not a polynomial because there is what we call a cusp or a sharp turn. And in the bottom, it is discontinuous because there is a jump discontinuity for this graph. So this would not be a polynomial function, but the left-hand side would be. Steps to graphing polynomial functions is the first step is to look at the highest degree, then look at the leading coefficient, whether it's positive or negative. So again, you're looking at this point, you're looking for if it is positive or negative. And then you are looking for any x-intercepts and y-intercepts. So first, to discuss parent functions, these are where polynomial functions are coming from, what the original graph looks like. So if the highest degree, the highest exponent, if it is even, it is going to look like one of these bottom functions down here. They are both going to be heading up to infinity, or if the coefficient is negative, it would be down to infinity. On the right-hand side, if the highest exponent or degree is odd, then it is going to go from a negative infinity on the left-hand side up and continue through a positive infinity. Depending on the degree, they are still all going to have what we call the same type of end behavior. So speaking of end behavior, if it is an odd, so we are starting with odd degree. So we're starting with something like x cubed, x to the 5th, x to the 9th, x to the 21st, anything with an odd degree. If the leading coefficient is positive, as x heads to negative infinity, which think negative infinity this way, this graph is heading down, which means the function is heading to negative infinity. As x is approaching infinity, which in this case would be the right-hand side, then the function is also approaching infinity. It is heading forever up. If the leading coefficient is negative, for example, a negative x cubed or a negative x to the 9th, then as x is approaching negative infinity, which again is to the left, the function is actually going up. So positive infinity. And as x is approaching infinity on the right-hand side, this function is actually going down to negative infinity. That is what we would call the end behavior. Again, this is for an odd degree. If it is an even degree, for example, we're looking at x squared, x to the 4th, x to the 10th, then if you notice, the function is going the same direction from the left and right. So if we think negative infinity and infinity, as x is approaching negative infinity, the function is going up. And as x approaches positive infinity, the function is still going up. And then if the leading coefficient is negative, so like a negative x squared or a negative x to the 8th, then the function is going down in both scenarios, negative and positive infinity. So as x approaches negative infinity, the function is also going to negative infinity. And as x approaches a positive infinity, the function is still going down. So for all end behaviors, the function is actually heading in the same direction. Same thing for negative infinity. Both the left-hand and right-hand side are both going down, or the left and right-hand side are both going up. So for an example, if we're wanting to know the end behavior and to graph, what we're looking for is just the first we're looking for the highest degree. So we're looking for the fact that this is an x to the fourth, but because there is a negative in front of it, then I know that the graph is going to look like this. It's even, which means they go in the same direction. And because it's negative, it means they're going down. So we don't know anything else that's happening with this graph, but we don't know what's happening in the middle right here, but we both know that it is going down from the left-hand side and from the right-hand side. So we will say as x approaches negative infinity, meaning you're going left, then the function is heading down. And as x approaches positive infinity, heading to the right, the function is still going down. And that would be your answer. So this is slightly different because of how this is written. This is written in what is called factored form. The above is written in called standard form. Standard form is when you go from highest degree to lowest degree. Factored form is when you are going, when you have parentheses next to each other that the function is in. So here you are if it's in factor form, you're going to do what we're going to count the x's. So in this case, when we count the x's, we have an x squared here. And then if you distribute, technically you would write this out as x plus 4 times x plus 4 times x plus 4, and you would FOIL. But I do know that eventually, even if you FOILed it, you will still get an x to the third. So we have an x squared in this factored form. We have an x cubed from this factored form, which means I know that the highest degree is an x to the fifth. We don't care about anything else, but we do know that it is a positive x to the fifth. So this is an odd function, which means as x is heading to the left, the function is heading to the left. So that should be negative. And as x is approaching the right-hand side, the function is also approaching the right-hand side. So if you think of it like this, x to the fifth looks like that. We don't really know what's going on in the middle, but we do know that the left-hand side and the right-hand side are going in opposite directions. As it's going down, to the left, it's going down. And as it's heading to the right, it's going up. And so this would be our end behavior. Now, there is something called turning points that tells you how many times it's going to turn. So, for example, this function right here has 3 turns. 3 turns. So we are going to go down from up, so that is 1 turn. We're going to go up and then we turn and go down, that is 2 turns. And then we're going to go down and then head up, that is our 3 turns. So anytime it turns, because we know that this has 3 turns, that means we know that the function is at least an x to the fourth. It could be more. It could be an x to the sixth. Okay, we know it's even. Okay, why do we know it's even? Because the end behavior is both going up. So we know it has to be even. But we know it's at least an x to the fourth, which means it could be an x to the sixth, or it could be an x to the eighth, or so forth. But we do know that it cannot be an x squared because there's 3 terms. So it can't be a degree that's anything smaller than the number of terms. It has to be at least 1 more than that. So in this case, we are going to determine 1, is it a polynomial function? And we can go ahead and say yes. it is a polynomial function. Now, then we're going to figure out how many turning points, where it goes up to down, it goes down to up, and then up to down. So there are 3 turning points. Which means it has to be at least one more than that, which means it has to be at least an x to the 4th. And this could be an x to the 4th because this is an even function, which means it can't be an x to the 5th. It can only be x to the 4th, and x to the 6th, and x to the 8th. Again, because it's an even function. Both the left-hand side and the right-hand side are heading in the same direction. And now, because the left-hand side and the right-hand side are heading down, we know that the leading coefficient is negative. So we know that a possibility is a negative x to the 4th as a leading coefficient. Next, we have what is called multiplicity. If the multiplicity is odd, the graph will cross through the x-axis, meaning it will physically cross the x-axis and keep going. If the multiplicity is even, that means that the graph will bounce off, meaning it will head towards the x-axis and then touch it and bounce off if there is a multiplicity of a 0. So in this case, if I was to want to find all the zeros, to find all the zeros, it has to be in factored form. So therefore, in this case, I would be able to factor out an x squared, and I would have an x squared minus 1. So I'll have an x squared, and then I would have an x plus 1 and an x minus 1. So now we set this equal to 0 because we're looking for everywhere across the x-axis. So it's going to cross at x squared is going to equal 0, x plus 1 equals 0, and x minus 1 equals 0. So this is a multiplicity. There's a multiplicity of 2 at 0. Here, x is negative 1, and here x is a positive 1. So I know that it is going to cross. I can even say cross here because there's no even multiplicity, and I know it's going to cross here at 1. And then at 0, it is going to bounce because there's a multiplicity of 2. Why is there a multiplicity of 2? Because the exponent is even. So it is going to bounce. Now, next thing you look for is you're looking for the highest degree. This is an x to the 4th, which means it is an even function, which means it heads to infinity on both sides. And now we should be able to figure out how to actually graph this. It crosses at negative 1, and it needs to turn to head back to 0. But remember, at 0, it bounces. So as it heads to 0, it is going to touch and bounce. And then it needs to turn again to head to 1, and it crosses through 1 and then heads to infinity. And this would be a very, very rough sketch of this graph. Now, there are actually a different type of multiplicity. If the multiplicity is odd and greater than 1, meaning an x cubed, an x to the 5th, or so forth, then it is actually going to look a little different. So for example, here, it is odd so it's going to cross through the graph. Here, it is going to bounce because the multiplicity is even multiplicity. Here it's going to cross because it is an odd multiplicity. And that is going to happen at 0. And then this one is going to happen at 2. Now, I know that if I was to count all of the x values, there are 5. There's an x cubed here, there's an x squared here. So I know that this is an x to the 5th, which is an odd function. It is a positive x to the 5th, which means I know it's going to start from down here and it's going to finish up there. So now here's where it looks a little bit different. When it's heading to 0, we know it's going to cross, but because this is a greater multiplicity, here's what happens. It's going to actually approach 0 as if it's going to bounce, but then it's actually going to turn and head in the opposite direction, and then it's going to turn back heading to 2, but at 2 it bounces off and then heads to infinity. So again, at this multiplicity, it turns from one direction and then turns back in the opposite direction if there's a multiplicity of a 3, a 5, a 7, and so forth. But at 2, because it's even, it automatically bounces. So we are going to sketch this graph. So I'd like for you to pause the video, attempt to sketch this graph based off of what we know of our end behavior, zeros, and multiplicity, and then resume to see the answer. So for this one, I can actually factor out an x cubed, and I'm left with 3x minus 4. And now I'm going to find the zeros. I know that there's going to be an x cubed equals 0, which means it is a multiplicity of 3 at x equals 0. And I also know there's going to be a 3x minus 4, which means x is going to equal 4/3. And it's just going to cross. Here, it is going to bounce. Nope, just kidding. It is not going to bounce. That is an odd multiplicity. It will cross. So at 0, we know it's going to cross. And at about 4/3, which is about here, it is going to cross. Next thing, we look at the highest degree. And it is a positive x to the 4th. So I know that it is going to go up in both directions from the left and the right-hand side. So we know that we're coming from infinity and we are heading down to 0. But we don't just cross 0. It crosses in a very weird place. So as it's coming up, that means it is going to curve as if it's going to bounce, but then it curves the other way at 0. And then we need to turn and cross through at 4/3. And that will be our sketch. Now, in this case, they tell us that the function has zeros at -1, at a +3, and a +5. We also know that at -2, I actually have a negative y. So at -2, it's going to be like somewhere down here. It's negative, as the y value is negative. And we also know that at f of 2, when x is 2, it also is going to be negative. We don't know where. We just know it's going to be negative somewhere below the x-axis. And then f of 4 is positive, and f of 6 is positive. So now we can sketch. We know that on the left-hand side of -1, it's negative, because at -2, it had to be down here. So we know it's going to head up through. It must have bounced. Why did it bounce? Because if it went above, we can't get back down here to the negative because there were no other zeros, so it could not cross the x-axis, which means it must have bounced to come back to something negative. And then from here, it crosses through to be positive, but it's got to be positive again on the other side, which means it must have bounced again to become positive again. So that is some type of sketch that we're going to have. Now we can actually figure out what that is. How many turning points are there? It turns here. That's one turning point. Here's another one, it turns. Here's another one, it turns. And here's another one, it turns. There are 4 turning points. So therefore, that means it must be at least an x to the 5th. It cannot be an x to the 6th because if you notice, this is an odd function. Because it heads in opposite directions. So therefore, it has to be either an x to the 5th or an x to the 7th or an x to the 9th. So to review, when sketching, we're looking at the end behavior. So in this case, because this is what we call the factored form, because these are parentheses, factored form is when you have parentheses. Next, we are going to count the x's. We have an x squared in this factor, and we have an x squared in this factor, which means this is an x to the 4th, which is even, so it's going to go up on both sides. So now we're going to find the zeros. We have x minus 2 squared equals 0, and we have an x plus 3 squared equals 0. So we know that at x equals 2, there is a multiplicity of 2 because of the exponent, and at x equals -3, there is also a multiplicity of 2. So at -3, it crosses, and at 2, it crosses. Because this is a positive x to the 4th, we know it's going to start from up here. We know it's going to bounce at -3 because the multiplicity is going to go up and turn back, and it's going to bounce again at 2 and then head to infinity.